Hello, I'm Daily. I had the fourth topic of organic structures, identifying and naming functional groups and general properties of functional groups. So a functional group, like what it is a specific, like how like the atoms are arranged in a certain molecule, and how it reacts. Its polarity, and like the physical properties of what it is. So I have a couple ester groups, a couple functional groups. It was the alcohol, the aldehyde, the amine, ester, carbolic acid, ketone, and a methyl group. And so they all have suffixes that you would use when naming. So for example, alcohol would be ol, aldehyde would be al, so al, amine is just amine, ester, it's also the same, just ester. The carbolic acid would be OIC, and then acid, and then ketone, I think it's own, it looks like one, or it's spelled like one, but I think it's own. And then I also have your methyl, which is also a methyl, just methyl, that's all it would be. I don't think there's anything too crazy with those, but I have an example with an alcohol group. Oh, let's go back first, hold on. So when you start naming, when you want to name, you want to name them, you want to find like the chain, like the longest chain, by like the highest priority of what the functional group is, and the highest priority is carboxylic acids, esters, amides, nitrile aldehydes, ketones, alcohols, amines, alkenes and alkynes, esters, and haldides. Sorry if I'm mispronouncing, these are out of my range, but and then so once you figure out like the highest priority, you're gonna number your chain, so like 1, 2, 3, 4, 5, 6, depending on how long your chain is, and then you're gonna use the suffix. So alcohol, for example, would be the ol, and so forth, and then you're gonna add your locals and assemble them by alphabetic for like the prefixes parts when you're like naming IUPAC names. So my first example is this one. So I am gonna find the largest or the longest chain. So I already did that. It's 1, 2, 3, 4. So that's butane, or yeah. And so I mean there's 4 carbons. And then this one's pretty simple because it doesn't have any other functional groups. It just has OH. And if I look on my board, that is alcohol. So that means the suffix of my thing, or like my chain or whatever, has to end with OL. So when you do this, you want to name name or whatever the molecule or structure. You want to have like the highest priority be like closest to, like when you name it, like 1. Like I wouldn't want to name this one 1 because you want to basically get rid of this quicker. If that like makes any sense, that's how I kind of interpreted it. And so I named it 1, 2, 3, 4. So OH is your alcohol. That was kind of a lot, but then so I already named it. It's butanol. So butan comes from the number of carbon in the chain, and the OL is the functional group, which is alcohol, as you can tell is alcohol. And then like a really, really simple one that like sometimes not tricks me up, but like sometimes I have to like, you know, go back into it and like study it, is like just like your basic methyl ethyl groups. Like I don't know why I always think it's something like an isopropyl, I don't know, I always get those really kind of confused. And so your methyl group, I have it, okay, this is not working really well. Right here is my methyl group. Okay, that was not a good photo of me, sorry guys. My methyl, and so that's 1, 2, 3, 4, And the reason why I named it 1, 2, 3, 4 and not 1, 2, 3, 4, because again, we want to have the highest priority functional group have a higher number when naming. And so your methyl group is basically just a CH3. And so, again, because it's 1, 2, 3, 4, that's 4 carbons, it's butane. So it would be 2-methyl butane. And that's basically like all I have. You just like want to like sum it all up is find the longest change. You want to use the suffix for the functional group, and then you want to, when you are naming, you want the highest functional group to be at a higher number, and then like down, and do them by alphabetical order. Thank you.